All right, so far we have studied in detail about lists, tuples, and sets. And obviously, we have talked about strings as well. Final data structure and a very important data structure, very much used data structure is called dictionary. Now, dictionaries are a little bit different than the traditional data structure. Overall concept is same. A dictionary is also used to store multiple values, multiple types of values. Another thing is dictionary is mutable, which means we can change the content of dictionary later on. But one thing which is not there in dictionary and which is actually there in every data structure is indexing. Okay. Actually, we have indexing in dictionaries as well, but we do not have the traditional indexing. Indexing do not start from 0, 1, 2, 3, 4, 5, and so on and so forth. Actually, what was the downfall of the other data structure was the following. For example, if I have stored a particular value at index number 99 or index number 1028 or something like that, it is very difficult for me to recall where was the value at which index that particular value is saved. So this problem is solved in the dictionaries. In dictionaries, values do not get stored in kind of indexing fashion. The values are stored in kind of key value pair, which means that each element of a dictionary consists of two elements. One is the key that acts like an index. Okay, so key is kind of an index of dictionary, and then we have a value. Now, as index is usually, not usually, but all the time it is going to be 0, 1, 2, starting from 0 and goes onwards. But key does not has to be a number. Key can be a string as well. What do we mean by that? For example, if I have to store information of students, I can store it like following. For example, first of all, I'll have to store the ID. So the key is going to be ID. It's going to be a string, right? So the value is going to be, let's say, ID is going to be 1, 2, 3. Okay. Then I have to store the name. So key is going to be name. And here I'll store the name, let's say, Zia. Okay. And then maybe I'll have to store the age of the student. So age is going to be, since age is going to be a number, so a number should be, number should not be in strings, right? It should be numerical. Oh, by the way, ID should also be numerical, but sometimes IDs consist of numerical and string letters, a combination of numerical and English characters like L, 1, 2, 3 or something like that. So let's keep it string, but age is going to be integer, right? And finally, maybe marks, right? And let's say we have to store marks of multiple subjects, maybe. So since we have multiple subjects, so let's create a list. So marks of first subject are going to be 20, second subject are going to be 24, and marks of third subject are going to be 18, like this, right? Now, if you look at the values, we are able to store values, different values, first of all, then the values from different data types. Again, here we have string, we have integer, and then we have a list containing integer, right? If we come out to the keys, so far we are storing only the keys as string, but yeah, we can store it as integer as well. Right now, integers are not making any sense over here, but we can do that. Later on, I'll do that in Jupyter Notebook, just to show you how it works. Okay. Now, just to summarize it, this is how I will store the data in a dictionary. But what if I have to access the name? Now remember, I do not have to recall what is the index of the value where my name is stored. Why? Because now I have the keys stored in natural language, right? I'll say, okay, fine. For example, what is the name of this whole dictionary? Let's call it DCT. Okay. So if I have to get Zia, so Zia is at location number name. Yep. And I'm able to access Zia. I don't have to go with the numbering anymore, right? That is, if I want to access ID, I'll write ID over here, right? That is how it works. Rest of the principles are same. Once, right now, the whole thing is the dictionary. But once I am accessing Zia by doing this, DCT and then indexing operator, and then name, right? DCT of name, it gets me Zia. Now this whole thing becomes what? It becomes a string. Why? Because Zia is a string, right? DCT of age will become integer. Let's go ahead and do some practical stuff and see if it works or not. Where is our Jupyter? Here it is. Okay. So first of all, let's create the dictionary. What is the symbol of dictionary? The symbol of dictionary is these curly braces or flower braces. You might be saying that, hey, these curly braces or the flower braces are the symbol of the sets, right? Yes, you're right. But there's a tiny difference between dictionary, representation of dictionary and set that makes both of them different from each other. In sets, we write values with comma separations, right? Whereas in dictionary, we have key value pair. So first of all, I'll say ID. First of all, we will write the name of the key, okay? Then colon, and then the value, okay? So ID was, let's say L123, okay? And then comma. Now this is the difference. This whole thing, including this colon sign, becomes one element, whereas in set, in list, in tuple, there is nothing apart from comma inside the whole data structure, right? Why? Because here in other data structures, we only have to store the values, but in dictionary, we have to store key value pair. And key value pairs are distinguished or separated via colon. Remember, it is colon, it is not semicolon. That is one thing. On left hand side, we'll have key. On right hand side, we will have value, right? So right now we have ID, then comma. Comma will separate the whole element from each other. The next element is going to be the name, and then colon. What is the name? Name is going to be Zia, then again comma. Then we have age, colon. What is the age? Age is, let's say, 18. And finally, again comma, we will have marks, okay? So marks are going to be what? They are going to be list. So let's say 20, let's say 24 and 80, right? So this is our dictionary. So if I run it, and I'll show you how it looks like, this is how it looks like, one whole dictionary. If I want to access any particular element, how do we do that? DCT. And then if I want to access ID, I'll write ID over here. ID, and I'll get the string over here. If I want to access age, I'll simply write DCT of age with capital A. Remember, again, the case sensitivity is still there. If age is written with capital A, you should also write capital A over here, right? So DCT of age, it says 18. Now this 18 is an integer, right? So if it is an integer, then we can do something like +2 as well, right? This can also work. Second thing is, as I mentioned, dictionaries are mutable, which means that we can change the content of the dictionaries as well. So DCT of, let's say, of age with capital A. If I say it is equals to, right now, what is the age? Age is 18, right? So if here I'll say age is going to be 999. You might be wondering that if 999 is my favorite number. No, I'm just writing 999 so that it is, separable from the existing characters. So running it, and then I'll say let's output dictionary, and here we go. Now age is 999. So some lucky guy, some lucky student is still studying at the age of 999, right? Cool. So mutability is still there. If we want to access any element of the marks, we can also do that. DCT. First of all, what is the type of DCT? It is dictionary. And if I say DCT of marks, if I run it, it shows me the list of marks that we stored over here. Okay. If I check out the data type of this thing, it is a list, right? Now, DCT is a dictionary, but DCT of marks is a list. Since it is a list, so we can perform list operations on it. For example, if I want to access 18, I have to further index it, right? So I'll write, again, indexing operator. So 18 is at 0, 1, 2, second index. So I'll write 2. So I'll get 18. I can also update it. So this equals to, again, 999. Okay. And then if I show you DCT, here we go. So the marks that were 18, now they are 999. Does that make sense? I hope that makes sense now. Okay. Moving on. And just to show you, I'm going to create another dictionary over here. Let's call it D, only D. Or maybe let's call it DCT2. Okay. So here, what I'm going to do is I'm going to say 12, colon. Now 12 is going to be the key. And since I'm not writing any quotation marks over here, so 12 is going to be an integer. Okay. So integer, I'm just going to show you integers can also be a key. Okay. So 12 colon, let's say 12 colon 2222, 222, and then again 12, but this time this 12 is in string. Okay. This colon, let's say string 12, right? So if I show you, I showed DCT, but we have to show DCT2. So here we go. So 12 is representing 222 and 12 in string is representing string 12. So if I will access any of these elements, if I'll say DCT2 of 12, it will get me 222. And if I write quotation marks around 12, it will get me string 12, right? Which means this 12 is integer as a key is different than the same 12 is in the string as the key. Okay, I hope that is very much clear to you guys. So now next thing is, let's quickly go ahead and filter the list. Filter the dictionary. So here we have only one dictionary, right? What do I want to do is I want to have multiple dictionaries and then I want to filter them out. By the way, we can also iterate over the dictionaries as well, but for that, dictionaries have to be in the form of list. What am I saying over here? Let me show you. So here, let's write a few more lines. Okay, so let's call it D1. Okay, so here we have ID, name, age, and everything. Let's make this age equals to 16. Okay, let me copy this, paste it. So we have 3 students now. Age is going to be 20 over here, and here age is going to be 24. Name is going to be, let's say, ABC. Oh, let's make it Tom. And here, let's make it Cat. Okay. And IDs should also be changed. So 1 to 4 and 1 to 5 are going to be the IDs. The variable names should also be changed, D2 and D3. Coincidentally, marks are still same. Okay. So now we have 3 dictionaries. Okay. I can show these dictionaries like this as well. This is D1. This is D2, and you can check out D3 as well. Now, what I am going to do is, I'll say list of dictionaries, okay? Or maybe I'll say list of students is going to be here. Remember, what is this? Symbol of a list, okay? In this list, if I store 1, 2, 3, then it is going to be a list of some integers. But if I say D1, what is D1 now? D1 is this whole dictionary, right? Comma, D2 is this whole dictionary. And then finally D3, which is this whole dictionary. Now we have a list of dictionaries. Let's show it, how it looks like. List of students, so here we go. So here you can see the symbol of list, the square brackets. Inside square brackets, just like we have 1, 2, 3 in a normal list, here we have as a first element, we have one dictionary, and then we have a comma, which means this is going to be our second element. Then we have comma, which means this whole dictionary is going to be our third element. Okay. Now, this is, since it is a list overall, if you may allow me, I'll show you the type. So overall, this is a list, as you can see over here. And I can also do something like this. List of 0, it will get me this whole first dictionary, because this whole first dictionary is at 0th index, right? Second dictionary is at second index, get. Okay, fine. If I want to access, let's say, a name of Tom, how should I do that? Tom is at, this is 0th index, this is first index, right? So I'll say list of student of first index. So here I have Tom. Tom is in the index of name. Now, this list student of 1 is going to be a dictionary. It is not a list anymore, right? Because we have indexed it. So here I'll say name. Running it, we got Tom, right? Okay. Finally, I am going to show you how we can filter the dictionaries or lists. Okay. For example, I want to filter all the students who are adults. The definition is adult is anyone who is above 18 years old, right? Greater than or equals to 18. So Zia should not be in the list, because Zia is 16 years old, and Tom and Kat should be in the list, or should be in the output, right? So what will I do? If I have to iterate over a list, what should I do? I should write a for loop. So I'll say for DCT, or let's say student in list underscore students, list of students. Okay. Now here in iteration, one student is going to be this whole list. Let me show you. Okay. Student. Yeah. So at the first instance, the student acts as a whole dictionary. At second instance or second iteration, student acted as a whole dictionary. Okay, so if I just want to print the names, or let's say ages, so I'll say age with capital A. So here we go. At first instance, at first iteration, student was this first dictionary. And from first dictionary, I'm printing out the age. So we've got age over here, right? And then second iteration, and then third iteration. Okay. Now, what was the goal? Goal was to filter the ages, right? So I'll say if student of age is greater than or equals to 18. If this is the case, since age is an integer, right? So I can use comparison operator over here. If this is the case, then do what? Then print out the whole record of the student, right? So running it, there we go. Tom with age 20 is printed, Cat with age 24 is printed, Zia with age 16 is ignored, right? So this is how we can apply filtering over a dictionary. Okay, I know this video is getting too long, but a very, very, very important concept I want to mention over here. Very important concept, okay? So listen to this very carefully. I'll talk about the dictionary that we created before, DCT. Okay, so we have it over here. Okay. Now, remember, if I do something like DCT of age, okay, and if I want to update any value, right? If I'll write any value over here, for example, I'll write 888 now. Previously, it is going to be, it was 999. If I write any value over here, what actually happens? Again, I repeat, it is very important. So please listen to this very carefully, otherwise you will be confused. So 888 will be assigned to a key that is already there, right? So it will basically, dictionary will search out for the key. If this key already exists, yes, it exists. Okay, fine. So update its value, right? This is how it will work. So if I run it and then I show you DCT again, yeah, you see the value is updated. But if I do something like this, DCT of, let's say, address, okay? And this address is going to be 12/B and blah, blah, blah. Okay, this is going to be the address. Now remember, I am accessing the same DCT, the same dictionary which is there. I want to write some value, some string over there by using assignment operator. So far, so good. But this key does not exist over here. We only have ID, name, age, and marks as a key. Address is not existing key, right? So what will happen? Do you think it will give me an error? Let me run it. No, it did not give me an error. Let's see what is DCT. So DCT has added the address over there. So in one line, if you're using assignment operator after creation of dictionary, if you're using assignment operator and key already exists, then it will update the value. And if key does not exist, then it will create a new value. Then it will create a new key value pair like this. Let me repeat, this is very important. If a key already exists, then it will update the value. If a key does not exist, like this address, then it will create a new key value pair in that particular dictionary, right? As I mentioned, dictionaries are mutable, right? So I know video got quite longer, but dictionary is a long topic. So our mini project of this whole data structure is also about dictionaries. That is coming up in next video.